Hello, I'm Pushkar and I'm Master Teacher in Chemistry at Vedantu and I'm discussing Chemistry Advanced 2020 paper. Now here is a question, very interesting question of the thermodynamics. 1 mole of an ideal monatomic gas at 900 Kelvin, temperature initially was 900 Kelvin, was subjected to this kind of a process in which it has taken from P1 V1 to P2 V2, process 1, and then from P2 V2 to P3 V3 in the process 2. Both processes are reversible, paths are well defined as shown in the figure. Work done in both the processes are same, but the strange thing is that U by R is given on the y-axis and S is given on the x-axis. So this at a moment it seems to be a difficult question. But then when you see it in applied thermodynamics, since it is a straight line, that means entropy in the first process is constant. And that has given us a clue that if entropy is constant, that it must be a reversible adiabatic process for which delta U is equals to W because Q is always equals to 0. First hint is this. Second hint is that 2250450, that means 450 minus 2250 is equals to minus 1800, and this minus 1800 is equals to, of course, delta U by R because R is not going to change. So that means this value is what? U1 by R, and this value is what? U2 by R. So U2 minus U1 by R is equals to minus 1800. And that gives us the value of delta U in this process is equals to minus 1800 R. So these are some clues in the problem. The first process delta U is this. Now delta U must be equals to W. That means delta U must be equals to W. So that gives us the value of W. So W must also be equal to minus 1800 R. So these are the facts which you have to use. Also, CV is given as to be 5 by 2R. CV is given in this 5 by 2R. So that is going to give us the clue that delta U is always equal to CV into delta T. And delta T is what? Initial temperature was 900. So T2 minus 900. And that must be equal to minus 1800 R. So this also give us some clues. So from there we can get, if we substitute the value, okay. So let's solve the problem. So these are the initial temperature was 900 Kelvin, as we have seen that delta U in this process is equals to W is equals to minus 1800 R. Okay, so internal energy is decreasing. That means W1 is equals to W2. So let us calculate first T2. So 5 by 2R, which is CV into T2 minus initial temperature 900, must be equal to minus 1800 R. So R is cancelled and we left with what? T2 minus 900 is equals to 3600 upon 5 with a negative sign. So that is equals to 5735 and 720 with negative sign. That gives T2 is equals to 180 Kelvin. So that means temperature here is 180 Kelvin. Initially temperature was 900 Kelvin. And in this process, we have seen that internal energy is going to be the constant, and it is an ideal gas process. So naturally the temperature here also must be 180. So this process must be what? An isothermal process. So second process is isothermal process. In an isothermal process, the work done is given by W is given by minus RT, since 1 mole of gas is involved, ln V2 by V1. So this is equal to, however, minus 1800 R. So 1 R is cancelled. T in this case is equal to already calculated 180. So from this we are going to get ln V2 by V1 is equals to 1800 upon 180, which is equal to 10. So a beautiful problem with no calculations, but all concepts. By all standards, this is a good question. A lot of small facts you have to apply, total conceptual problem. And I like this problem very much. These kind of questions is really good, go a long way in, I mean, giving students, motivation to study deeply. So stay tuned for other such solutions. Thanks for watching.